Hi, welcome to another video on trigonometric ratios, and specifically for this video we'll be looking at how to find unknown angles. To learn how to find unknown sides using trig ratios, please go back to my previous videos that I uploaded on how to do so. Alright, I also went through how to identify right angle triangles and also how to label the sides of a right angle triangle in relation to the tangent, the sine, and the cosine. Alright, so let's move into our first question. So calculate the missing angle in each triangle below. So I have 3 examples, so this is the first one. So first thing you'll need to do is to identify the trig ratio that you need to use. Alright, so let's go ahead and carry that out. Okay, so in relation to where the angle is positioned, first thing you would do is label the sides of the triangle. So this side that has the 12 centimeters, that's a hypotenuse. The side opposite to theta, that's called the opposite, and this remaining side is the adjacent, ADJ. Alright, so we need to calculate the angle right here, which is theta. So you pay attention to the 2 sides that you were given. So you were given the adjacent side and the hypotenuse, and the trig ratio that corresponds to this is the cos trig ratio, which says cos theta is equal to adjacent over hypotenuse. So we write that out. Right, so we go ahead now and do the appropriate substitution. So cos theta, remember we don't know what theta is, that's what we want to find, so we put theta as it is, equal adjacent over hypotenuse. Adjacent is 8, hypotenuse is 12. Alright, so we'll go on next further now. You can change this to a decimal if you want, as in do the division and then you put the answer, right? And we're gonna carry out that. So cos theta equal, we're gonna do this to 3 decimal places, 0.667 to 3 decimal places. You could leave it as a fraction, but I'm gonna do it as a decimal for this one. So you divide the 8 by the 12. And what we're going to carry out here is what is called the inverse trig function concept, where we need to leave theta by itself in order to find what theta is. So what we'll do, theta equal to cos inverse 0.667. And normally to get to this inverse function on your calculator, you normally press second function on your calculator or shift, right? And these buttons will bring the calculator to a higher function. So if you should press second function or shift and then you press cos, you would see this come up on the calculator, cos inverse. But if you don't press second function and you press cos, only cos will come up. But once you press second function and press the cos button or the cosine button, this is what will come up. So always remember to carry that out. So I'm gonna plug this in my calculator now and see what I actually get. So I press second function, and then right, so when I plug that into my calculator, I get 48.2 degrees. So this part is the tricky part, but it's not that hard. So you press second function when you reach right here to find out what theta is. You're gonna press second function or shift and then press the cos button. Once you press the cos button, you should see this come up on your calculator. And once you see that come up near, you can put this in bracket 0.667, then you press equal, and that should give us the answer. So theta right here is 48.2 degrees. Alright, let's move on to the second example. Alright, so first thing we do is to identify the trig ratio that we are going to use. And based on what is happening here, we are given the hypotenuse and we are given the opposite. So opposite and hypotenuse, which trig ratio relate those two sides? That would be the sine trig ratio. Sin sine theta equal opposite over hypotenuse. And the procedure is just the same. So we need to find theta. So sine theta, put back theta because we don't know what the angle is as yet, equal opposite, that's 10 over the hypotenuse of 12. Remember, same procedure, nothing really difficult here. Right? And you can carry out the division as I said, but you can plug it in a calculator as a fraction. But once we get a bit more flexible with the calculator, we can treat it as fraction. But let's do the division right here. So we have 10 divided by 12. That gives us 0.833. We're gonna do it to 3 decimal places. So remember what I said, when we reach this part, we want to leave the angle by itself. So we have angle as theta equal sine inverse, SIN, tan inverse at the top, and you have 0.833 right there. Now remember the second function button or the shift button, SHIFT. This will bring the calculator to a second level of operation. So once you press that shift button, then this comes up, sine inverse. Press the sine inverse and then you input 0.833. 0.833. Alright, you can put 0.833 in bracket, and that will give us an angle of 56.4 degrees. So this angle right here is 56.4 degrees. So please remember one of the most important things to do here is to identify the sides correctly, because if you identify the sides correctly now, this will give you a good chance to select the right trig ratio. Because if you select the wrong ratio and you carry out a calculation, even when the calculation looks logical, your answer will be off because you didn't select the right thing. So third and final example now. If we look at the triangle, we are given the opposite side with the 14 and we are given the adjacent side. So opposite and adjacent, which trig ratio relates to those two? Opposite and adjacent, that looks like tan. So tan theta equal opposite over adjacent. First thing, get your ratio correct, then we carry on. So tan theta, put back theta because theta is what we want to find. We don't know theta yet. Equal opposite. What's the opposite side of the triangle? That is 14 and the adjacent side is 8. Alright, so let's carry out the division right here to simplify this process. This gives me tan theta equal 1.75. Remember the procedure, we need to get theta by itself, so we have theta equal tan inverse 1.75. Remember the second function or the shift. Once you press second function or shift, your calculator function should change, and then theta is equal to, after you press shift or second function, you press tan, and then you can put 1.75 in brackets. But when you press tan inverse will come up and you put 1.75 in bracket. Alright, in bracket equal, and I have an answer of 60.2 degrees. Alright, so this angle right here measures 60.2 degrees. I hope this video helped a lot, and these are, if you notice, I exhausted the 3 basic trig ratios right here. So the same concept applies despite the numbers or the length of the sides that you get. So thanks for watching, and please subscribe to the channel and stay tuned for upcoming videos. Thank you.